truth seekers, you can use science to perform magic tricks and enhance any magic show. These tricks are great for use as science projects or just for fun. The tricks also work as memorable science demonstrations. 1. Burning money trick. Set money on fire and watch it burn out without damaging the bill. This is a nice magic trick based on everyday chemistry that makes a good introduction for a discussion about combustion. If you repeat the trick with paper instead of currency, the paper will burn. Do you have money burning a hole in your pocket? It's probably not a wise idea to soak a $20 bill in a flammable liquid and set it on fire, but that's what you'll have to do in this science demonstration. Sure, you could just use a $1 bill, but then you won't sweat as much. Rule number 1, never use your own money. Borrow a $20 bill from your friend. If you can get away with this, you have incredible skills of persuasion. Otherwise, cough up your own money. Then, dip the bill into the mixture of water and rubbing alcohol using the tongs, and make sure the bill gets completely soaked. Afterward, remove the bill using the tongs and gently shake off any excess liquid. Later, move the water-alcohol mixture to a safe place, away from the area where you are going to light the bill on fire. Here comes the magic. Hold one end of the bill with tongs and light the bottom of the bill with a lighter. The bill will look like it's burning, but it shouldn't burn, famous last words. When the flame is completely extinguished, it's safe to touch the money. You'll find that the money is even cool to the touch. Warning. Important safety rules. This demonstration should not be attempted without strict adult supervision. What's the secret? Alcohol burns with an almost invisible blue flame. One trick is to add a little table salt to the water-alcohol mixture to give the flame a more yellowish color and make it more visible. You can also try to change the ratio of rubbing alcohol to water to see how it affects the way the bill burns, but you're likely to accidentally burn up your dollar bill. 2. Water into wine trick. This magic trick involves changing a clear liquid into a red liquid. The magic is reversible, so you can alternate between red and clear. This is a very simple but exciting trick when conducted by a true performer. It demonstrates the nature of indicators in identifying acids and bases the solubility and acidic nature of carbon dioxide when dissolved in water. You can amaze your audience by proving that you also can turn water into wine, but only you can turn the wine back into the water. You will need phenolphthalein, sodium carbonate, wine glass, straw. Place a very small sample of sodium carbonate at the bottom of a wine glass. Small enough so that it is very difficult to detect. Drop a few drops of phenolphthalein into a cup of water and use this cup to fill the wine glass. The water should turn red, pink when it enters the wine glass. Now, you know Mum disapproves of you drinking wine and asks you to change it back to the water. Now here is where playing with your food gets interesting. Blowing carbon dioxide from your exhaled breath into the wine will turn it back to clear water, and this should please Mum. Students can make movies that relate to the magic of science in a comical setting. This video depicts young Jesus playing with his food while doing his homework. Vinegar was used to change the wine back into the water. Why does vinegar make the red water clear? 3. Hot ice. Turn a clear liquid into what appears to be a block of ice, instantly. As the liquid crystallizes into ice, it generates heat, which is why the material is called hot ice. Another way to perform this trick is to have the liquid turn into a solid while you pour it. You can form hot ice mounds and towers and watch as the crystallization proceeds from your dish into your original container. Imagine saying to people, "I can make hot ice." They wouldn't believe you, would they? As far as science theory goes, they shouldn't. We know that in order for ice to exist it has to be at 0 degrees and that once heated it would melt. However, we can fool them into thinking we have made hot ice with this trick. First, you have to set up the solution. Making hot ice is a simple process, and you probably have everything you need on hand. You'll need a couple of hours, though, so keep that in mind. For this you need baking soda vinegar concepts illustrated. Supercooling crystallization exothermic chemical reactions time required. From start to finish, this experiment takes about an hour. Once you have the hot ice, you can quickly melt and recrystallize it. Level: beginner to intermediate level notes. The chemicals in this experiment are non-toxic. However, because liquids are boiled, adult supervision is recommended. This project is best for middle school and above. Sodium acetate or hot ice materials: 1 liter clear vinegar, weak acetic acid, 4 tablespoons baking soda, sodium bicarbonate. Prepare the sodium acetate or hot ice in a saucepan or large beaker, add baking soda to the vinegar, a little at a time, and stir between additions. The baking soda and vinegar react to form sodium acetate and carbon dioxide gas. If you don't add the baking soda slowly, you'll essentially get a baking soda and vinegar volcano, which would overflow your container. You've made the sodium acetate, but it is too dilute to be very useful, so you need to remove most of the water. Here is the reaction between the baking soda and vinegar to produce the sodium acetate: Na+, HCO3, plus CH3COOH, right pointing arrow, CH3COONA+, plus H2O plus CO2. Boil the solution to concentrate the sodium acetate. You could just remove the solution from heat once you have 100 to 150 milliliters of solution remaining, but the easiest way to get good results is to simply boil the solution until a crystal skin or film starts to form on the surface. This took me about an hour on the stove over medium heat. If you use lower heat, you are less likely to get yellow or brown liquid, but it will take longer. If discoloration occurs, it's okay. Once you remove the sodium acetate solution from heat, immediately cover it to prevent any further evaporation. I poured my solution into a separate container and covered it with plastic wrap. You should not have any crystals in your solution. If you do have crystals, stir a very small amount of water or vinegar into the solution, just sufficient to dissolve the crystals. Place the covered container of sodium acetate solution in the refrigerator to chill. Note: if you boil your solution at a higher temperature, it may turn yellow-brownish, but don't worry, the experiment will still work. Next, I poured the concentrated sodium acetate into a glass Pyrex measuring cup and placed it in the fridge to cool, and scraped a little bit of the dried sodium acetate powder off the inside of the pot to use later. After about 30 to 45 minutes, the solution was cool enough to turn into ice. I grabbed my glass dish and placed a small pile of sodium acetate powder from the pot in the center. This would act as a seed for the crystals to start forming. 4. Egg in a bottle. With just a few household items, we can show you how a hard-boiled egg can squeeze right through the mouth of a bottle. The egg in a bottle trick is a science classic, dating back at least 100 years. It's a brilliant method of teaching just how powerful air pressure can be, and the trick is also a great way of messing with your friends. We won't stop there, we'll also show you how to perform a gravity-defying version of the trick. It's an exclusive, upside-down twist. Firstly, carefully fill the balloon with water so the balloon is slightly larger than the mouth of the bottle. Tie it off. Make several water balloons just in case the first one breaks. Secondly, the glass juice bottle should have a wide mouth between 11 halves and 2 inches in diameter. If you can find an old-fashioned glass milk bottle, use it. Rinse out the bottle to remove any leftover, sticky, slimy stuff that might be at the bottom. Here's the challenge. Your job is to find a way to get the balloon into the bottle without breaking it. How are you going to do it? It's important that you take a minute to test out some of your ideas before jumping ahead to read our solution. Keep trying. Once you've come up with your hypothesis, read on to find out your answer. Afterward, start by smearing some water around the mouth of the bottle. The water acts as a lubricant. The next few actions require some good teamwork. Set the glass bottle in front of you on a table. Make sure the water balloon and strip of paper are close by. The adult member of the team is responsible for lighting the strip of paper on fire and quickly pushing it into the bottle. As soon as the burning paper goes into the bottle, the second team member covers the mouth of the bottle with the water balloon. The burning piece of paper or birthday candles heat the molecules of air in the bottle and cause the molecules to move far away from each other. Some of the heated molecules actually escape out past the egg that is resting on the mouth of the bottle. That's why the egg or water balloon wiggles on top of the bottle. When the flame goes out, the molecules of air in the bottle cool down and move closer together, making room for new air molecules. This is what scientists refer to as a partial vacuum. Normally, the air outside the bottle would come rushing in to fill the bottle. However, that darn egg is in the way. The pressure of the air molecules outside the bottle is so great that it literally pushes the egg into the bottle.